I'm going to discuss problem number 54, section 5.1, page 335. It's the one about the Earth's core and finding different ratios. So the problem says the Earth core is divided into is spherical in shape, and is divided into solid inner core and a liquid outer core. It's much easier if you're looking at the picture while we're discussing this. And part A says the Earth's radius is about 5 times as great as the radius of the Earth's inner core. So find the ratio of the Earth's total volume to the volume of the Earth's inner core. Well, I'm just going to draw a little kind of a picture here without making it spherical. So I have my inner core, and then I have my total volume is going to be all the way to the edge. And what I'm told in part A is that the radius of my inner core, I will call it R, compared to my outer core, the outer core is 5R. The radius of the entire Earth is 5 times as great as the radius of the inner core. So we need to know that volume is equal to 4/3 pi r cubed. And let's just assign that, we'll call that the inner core volume. Well, the volume for the total Earth, we'll call it V sub E, is equal to 4/3 pi r cubed also, but in this case our r is 5 times as great as the radius of the inner core, so I'm going to make it 5r cubed. We'll call that total volume. And the question is asking, what's the ratio of total volume to the volume of the inner core? Well, if I'm going to find ratio, I'm going to put total volume over inner core volume, which is 4/3 pi r, no, 4/3 pi 5r cubed over 4/3 pi r cubed. Well, I think I would like to first cancel out my 4/3, and I'd like to cancel out my pi's. I'd like some pumpkin pie. And I'm going to have now 5r cubed over r cubed. That's the same thing as saying 5 cubed r cubed over r cubed. I've taken my power of 3 and applied it to both terms inside my parentheses. Well, now I can get rid of my r cubed, and I'm left with 5 cubed, which equals 125. So the ratio is 125 to 1 between the Earth's total volume and the volume of the Earth's inner core.